In this video, we're going to talk about modeling exponential and logarithmic functions. So up until now, we've used different skills algebraically and graphically to solve different exponential and logarithmic problems. Now we're having to put those skills in context to solve problems. So, a certain bacterium has an exponential growth rate of 25% per day. If we start with 0.5 gram, how much will we grow in 2 weeks? So, with these types of exponential growth and decay, we use a general formula very similar to the exponential growth and decay in a previous video called PERT, where R is my rate, T is my time, P sub 0 is my initial value, and then E is that irrational number from a previous video, roughly equaling 2.17. So using this formula, I simply take elements from my problem and substitute them in for values of the formula to solve. So P sub 0, or my initial value, is 0.5 grams. E raised to my rate, which is 25%, which I write as 0.25 because I have to write my rate as a decimal. And then time is 2 weeks. And then in the calculator, I plug in this equation and find that the amount after 2 weeks is equal to 0.824. Approximately. So, I need to put this in context of the problem, reinterpret it, and after 2 weeks, I have 0.824 gram of bacterium. But now, let's say we're asked how long for 1 gram to grow. So using that same PERT formula, I have the same initial value, I have the same rate, time, how long, time is what I'm looking for, and my P is 1 gram. So to solve this, I have to use logarithmic functions. First, I need to get rid of this coefficient, and so I would divide by 0.5, which gives me 2 equal e raised to 0.25t. And in order to bring this variable down, so in order to solve, I have to switch this exponential form of an equation into a logarithmic form, which was what we did in a previous video. Typically, we would write log base, whatever the exponent base is, but since we don't have a log base e, we have to use the log specific for e, which is the natural log. Also discussed in a previous video. The natural log we write as ln of 2 equals 0.25t, and then to solve I would divide by 0.25, and then in my calculator I would say ln of 2 divided by 0.25 gives me approximately 2.773. And then I need to reinterpret. So approximately 3 weeks, in approximately 3 weeks, I will have 1 gram of bacterium. This is why we learned all of these different skills of exponential and logarithmic functions, so that we could solve these types of problems